Chapter 7, Lesson 6, Cross-sections. You will be able to identify and draw cross-sections of three-dimensional figures. A plane is a flat surface that goes on forever in all directions. The figure at the right shows rectangle ABCD. Line segments AB and DC are coplanar because they lie on the same plane. They are also parallel because they will never intersect, no matter how far they extend. Just as two lines in a plane can intersect or be parallel, there are different ways planes can be related in space. They can intersect in a line, they can intersect at a point, or they can have no intersection, in which we would call them parallel planes. Intersecting planes can form three-dimensional figures. A polyhedron is a three-dimensional figure with flat surfaces that are polygons. Prisms and pyramids are both polyhedrons. Some terms associated with three-dimensional figures are edge, face, vertex, and diagonal. An edge is where two planes intersect at a line. A face is a flat surface. A diagonal is a line segment whose endpoints are vertices that are neither adjacent nor on the same face. And a vertex is where three or more planes intersect at a point. There are also solids that are not polyhedrons. A cylinder is a three-dimensional figure with two parallel congruent circular bases connected by a curved surface. A cone has one circular base connected by a curved side to a single vertex. Identify the three-dimensional figures. Identify the figure, name the bases, faces, edges, and vertices. Now this figure has two triangular bases that are parallel, so it's a triangular prism. And I'm just going to put all these labels up here and we'll talk about them. The bases are ABE and FCD. The faces are also your bases, ABE and FCD, as well as BCDE and FAED and ABCF. Your edges, AB, BE, EA, FC, CD, DF, BC, ED, and AF. And your vertices are your points here, A, B, C, D, E, and F. Letter B has one base that is a five-sided figure, so pentagon. So this is a pentagonal pyramid. So again, I'm going to put up what everything is, and we'll talk about it. Your base is the pentagon, which is RSTUV, which is also one of your faces. And then you have QVR as a face. And then we have QRS as a face. And then QST, QTU, and QUV are your faces. The edges are QR, QS, QT, QU, QV, and then VR, RS, ST, TU, and UV. And your vertices are QR, ST, U, and V. Our next figure has two bases that are parallel and in the shape of a rectangle, so they are rectangular. It is a rectangular prism. So our bases, which are also two of our faces, are A, B, C, D, and E, F, G, H. You could also say, as your bases, since it's a rectangular prism, you may be not so sure as to what your bases are. You could say it's A, B, F, E, and D, C, G, H, or you could say that A, D, H, E, and B, C, G, F are your bases. It's a rectangular prism, so it really doesn't matter which two are your bases. And all six of those are also your faces. The edges, you have AB, BC, CD, DA. Then you have EF, FG, GH, HE. Then AE, BF, CG, and DH. And then, of course, your vertices, A, B, C, D, E, F, G, H. Another figure we have here is a triangular base and only one of them. So it is a triangular pyramid. The base is JML, which is also one of its faces. Its other faces are JKM and KML, as well as JKL. The edges, we have JK, KL, and JL, JM, KM, and LM. And the vertices are JKLM. Cross sections. The intersection of a solid in a plane is called a cross section of the solid. Describe the shape resulting from the cross sections of the square pyramid. It's a square pyramid because the base is in the shape of a square. So if we were to look at just the piece of this cross section that's touching the pyramid, it's cutting through here and forms that shape, which is a triangle. Now the angled one, it actually is forming a different type of shape. See if I can draw that a little better here. There we go, which is a trapezoid. And this horizontal one, which is parallel to the base, which, by the way, is a square in this square pyramid, would be a square cross-section. Describe the shape resulting from a vertical, angled, and horizontal cross-section of a cylinder. So before I really get very far, I'm going to draw in some cross-sections here. angled and horizontal. Okay. So this cross section would look like a rectangle. This cross section would look like an oval. And the horizontal, which is parallel to the base, would be a circle. A rectangular prism here, this cross section would be a rectangle. Now this is a triangular pyramid. So this horizontal cross section would look like a triangle. And this cone would also have a triangular cross section.